Okay, so we reviewed logic. Now we're going to review some of the algebra. Okay, so just this notation again, the function notation. F of x always equals y, so whatever here gets plugged in for x. So when you do f of -7, you're taking the -7 and you're plugging it in wherever the x is. Oops, not -4. And notice how I put it in parentheses. Also, it's a great time to use your stow button in your calculator. Those of you that know about the stow button. Okay, great time for that. You calculate that all out and you're going to get 25. So whatever here, plug it in for x. You're going to take this here, plug 6 in for x. So 1/3 times 6 minus 2, plug that in the calculator. Same thing here, you're going to take -1. You're going to plug it into all of the x's. In my opinion, the stow button is your best bet. Otherwise, you have to be really careful with the parentheses on that. Okay, so again, consult the answer key and make sure that you're getting the answers that are on there. For 4 here, you're checking to see if it passes the vertical line test. In order to be a function, it has to pass the vertical line test, meaning if I draw a vertical line in anywhere, it can only hit the graph at one point. So this vertical line hits it one time. This vertical line hits it once. This vertical line hits it once. This is a function because it passes the vertical line test. This one over here, however, when I draw the vertical line right here, it hits twice. Therefore, it is not a function. It does not pass the vertical line test. Okay. Number 5. Finding the x-intercept. Remember, the x-intercept is when y is 0. So I always just write the ordered pair immediately. That tells me, okay, x-intercept is when y is 0. It's opposite. Y-intercept down here is when x is 0. It's always the opposite. So this tells me take 0, plug it in for y, and solve for x. So 6x, this is going to be 0 because anything times 0 is 0. And then I solve for x. Okay, so same idea down here. I'm going to take this 0, plug it in for x. This is going to disappear. And so we divide by -3, and we get -4 there. And notice how it says write as a coordinate. This is a coordinate. This is what it means. So you can't just say on number 5 here, you just can't say 2. It's an ordered pair, 2, 0. X-intercept, y is 0. Y-intercept, x is 0. Number 7, slope. Remember the formula for slope is y-coordinate minus y-coordinate over x-coordinate minus x-coordinate. So I'm going to start with this 6. So y minus the y-coordinate. Be careful, that is -4, so I have to put parentheses around it. Since I started with this 6, I have to start with this -4. -4 minus -2. Then if I were you, I would go right to the calculator, use your fraction button, plug that right in, and you should get -5. Okay, so you can try letter B. Again, consult the answer key. On these graphs, so when it is written in slope-intercept form, the y-intercept, which again is when x is 0, if I take 0 and plug it in here, this goes away. The y-intercept is -5. So that's where I'm going to start, down here. And then this is my slope. So I'm going to go up 3 over 4. So I went up 3, and then I went over 4. And I just keep doing that. Up 3, over 4, and I draw my line. Okay, so you always start at the y-intercept. This one you're going to start at 0, 3. And your slope here is this number in front, -1. So if I do that, -1 over 1. Now because it's negative on this time, so if the slope is positive like it was here, I always go up. If it's negative, I go down, and I always go to the right, just to make it easy. So because this is a negative, I'm going to go down, and then to the right. Down, and then to the right. And then there's my line. Okay, so you can try number 9 on your own. This one here, This one is set up completely for x and y intercept. So I would say your x-intercept, remember that's when y is 0. Y-intercept is when x is 0. So if I take this 0 and plug it in here for y, this disappears, and I'm only left with 2x equals 6, so that's 3. If I come back and plug 0 in for x, this goes away, and I solve, I get y equal to 2. I plot those points, and I'm able to draw that line in. If you want, you can come up here and you can solve for y, but in my opinion, when it's set up like that in standard form, your best bet is just to do your x and y intercepts, and it's a lot quicker. So down here is the same idea again, but you just have to be careful with solid and dotted lines. You're going to graph this just like you did before. Your y-intercept is 0, 2. Your slope is -2/3. This means it's going to be a solid line when you draw on the line. When you draw on this line, you're going to have a dotted line. And then you can't forget about the shading. Once you draw in your line, you have a couple of different options that you can do. So if I graph this quick, down 2/3, down 2/3, this is a solid line. So you have a couple of different options. If it's already solved for y like this, you can look here, and because that means less than, I know that my shading is down. That's one option. That means it's down below the line. If that was greater than, my shading would be up. Your other option is to find an ordered pair, like in this case 0, 0. If 0, 0 works, so if I plug 0 in for y and I plug 0 in for x, I end up with 0 is less than 2, which is true, so that's part of your shading. Again, you're in that shaded region. Okay? And then you'll do the same thing on the next one, but it's dotted. Just a reminder with vertical, this is a vertical line, and this is a horizontal line. So x equal to 5, 1, 2, 3, 4, 5, that's a solid line. And I want all the x values less than or equal to 5, so that shading is going to be over here. Now I'm going to do the y less than 2, so here's y less than 2, that's a dotted line. And it's all the y values less than 2, so that's below. And so you look to see where the shading overlaps, and it's right down here. So your final solution is always going to be where they overlap. This is your final solution. So all of these ordered pairs would make both of them correct. So same idea on this one, graph both of them and look to see where the shading overlaps. Again, if you remember how to do that in the calculator, you can change your shading based on the inequality, if you remember that. If not, no biggie, you can do it by hand. Look for where the shading overlaps. Okay, so check those answers on the answer key. Let's continue here with a little bit of a word problem or application. It says, what is the y-intercept and what does it look like in the concept, in the context of the problem? So here's your y-intercept. Y-intercept is when x is 0, so it's 0, 1800. And what does that mean? So if you look at our labels here, the y-axis is the car's value. So that means that year 0, the car value of the car is 1800, which means the original price of the car is 1,800. And again, that's written on the answer key. Letter B, x-intercept here. X-intercept is when y is 0, so that's going to be 6, 0. Look at the concept of the problem. When the car is 6 years old, the car is going to have no value because it's not worth anything at that point. Okay? Find the slope of the line. And what does it mean? The slope here, if you want to, you can do a couple of different things. You can literally count, rise over run, or probably your best bet is to take these two, whoops, I almost erased, these two ordered pairs and do your y minus y over x minus x. You're going to get 1800 minus 0 over 0 minus 6. which means that the slope is negative $300 per year. That means the value of the car is decreasing $300 every year. So the value is going down. And then when you're writing your linear function, if I say mx plus b, because I know the slope and I know the y-intercept here. My slope is the negative 300, and the original price was $1,800. Okay? Good luck.